In this video, we'll discuss the introduction to electrostatics. Now, when we say electrostatics, this is the branch of physics that deals with the phenomena and properties of stationary or slow-moving electric charge with no acceleration. So, this is actually near to at rest. So, when we say electrostatics, this is the electricity at rest. Now, there are many evidences of that shows electrostatic effect. One of these is the lightning. Lightning is actually the interaction between the cloud to cloud or cloud to ground charges, because the cloud stores charges, the ground also is a negatively charged. So interaction between the cloud and ground is a kind of lightning, so it will interact. Cloud to cloud also will have also an interaction, so the result is the electrostatic effect. So we can experience lightning. Simple evidence is when you are combing your hair, you are actually charging. So if you have the very light material, then it will be attracted by the comb. So these are only few of the evidences, but there are many. Like if you are walking the carpet, while walking you are charging, then when you are holding the doorknob, then you will experience an electric shock. So those are evidences of electrostatic effects. So why it happens that there is charge? So there are actually laws of electric charges. Law number one, we have the same charges repel each other. So if we have positive, it will repel. For negative, repel also. So the same charges repel each other. Law number two, different charges attract. So if we have positive and negatively charged, then it will attract each other. Then law number three, non-charged particle always attracted by a charged particle. When we say non-charged particle, the number of electrons have the same number of protons inside the material. So there is no unbalance of charges. So if there is no unbalance of charges, we call it as non-charged particle. So if we have this non-charged, the number of protons or the number of electrons, and this is actually deficiency in electron. Deficiency in electron means it is a positively charged, which means that the electron is outnumbered with the positively charged. So therefore, this is a positive charged particle. So the non-charged is always attracted by a charged particle. So this will be attracted, or maybe the charge will be attracted by the non-charged, depending on the status of the setup. So positive attract a non-charged. A negative also charge will attract the non-charged. So always attract. There's no repulsion. You can notice here the positive attracted by the negative, while the negative was being repelled by the object. So just like in positive also, the non-charged, but take note, the number are the same. We have 4 counts and we have 4 counts of positive. So the negative was attracted while the positive was repulsive. Okay, so that's it. These are the laws of electric charges. By the way, the paper, small paper is an uncharged material, while the comb is negatively charged after combing. So therefore, the comb charged by a negative, because this is a plastic, so the negative charge will attract the positive part of the small pieces of paper. Then that's the reason why it was being attracted. Now, another important in electrostatics, we should know the conductor and insulator. When you say conductor, it is a material that allows the electrons to flow, so it will conduct electricity because of their number of free electrons at the surface of the material. Then there are some examples of the conductors are, we have the copper material. It's a good conductor. Aluminum, gold, and silver. These are good conductors. So, in a wire, inside the plastic, inside is actually the conducting material. While outside is, we call that as insulator. So, the insulator is the reverse of conductor. If the conductor allows the current to flow, the insulator prevent the current to flow. So it makes a poor conductor if you are using insulator. So one good insulator are the glass, air, plastic, rubber, and wood. So in the case of the electric wire, usually the insulator is made up of rubber or maybe plastic. Okay, so wood are insulators. So therefore, if we use wood, we cannot, will the current cannot flow into the, or it will flow in a very very slow motion of electrons. Okay, so these are the conductor and insulator. These are very important because we are working with motion of electrons, so therefore we use the conductor. In order not to electrify, then we use the insulator. Okay, so when we see charging the particles, so there are plenty of method, no? So one of this is the induction. This is induction without contact. So the process of providing charge through induction is induced charge. So therefore, the particle can be charged by or acquire a charge by charging. So we call that as induced charges or electric charging. So again, we have two types of charging. One is the charging by conduction. From the word conduction, there must be a contact. One particle is being charged, the other is to be charged. So for example, I have this object and this is the material to be charged. This is a non-charged, and this, we have this as the insulator. Imagine this is an insulator placed on the ground. So therefore, this is actually isolated. This is non-conducting with the earth. So non-charged because the number of protons have the same number of electrons. So therefore, this is a non-charged particle. Suppose we want to charge this one by conduction. So we need something that has a charge. For example, I have a positively charged and I want to charge the non-charged particle. All you need to do is to use a conductor. Take note, this must be a conductor so that it allows the charge to flow. So in this case, the positive will be flowing or will be attracted to the non-charged particle. So until such time, okay, until such time that this will be fully charged. So therefore, in this case, the electrons will be outnumbered because the positive is keep on attracting towards the non-charged. So with time, this will be fully charged with positively charged. So when you remove this conducting material, then this will becomes a positively charged. So it will replicate to the source. So in conduction, the non-charged material will gain the same charge of the charged particle. So positive, positive. Now suppose we have the negative charge and we want to charge the uncharged using charging by conduction. So again, we need the conducting material, then we let the electrons to flow towards the non-charged in order to have the charging process. So the electrons flows into this non-charged. So in this time, the electrons will dominate its number. So more electrons means negatively charged. Deficiency in electrons, we call that as positively charged. This is more electrons, but it doesn't mean there is no protons. There's a protons, but it was outnumbered by the electron. That's why we call this as negatively charged. So therefore, once fully charged, remove the conducting material, then this will becomes negatively charged. So the same as the source charge. Okay, so this is charging by conduction. Another charging is induction. So when we say induction, there's no contact. So suppose again I want to charge this object non-charged by a charged object, but there's no contact. So all you need to do is to put this object closer together, closer to each other. So then notice that the negatively charged was attracted by the positively charged, but it can travel, unlike in the conduction. While look at the negatively charged, the positively charged was being repelled, but it will stay on the opposite side of the object. So this is by induction. The question is this in charging process? The answer is no. Why? Because once you remove this one, if you remove this, this will return to its proper place. So they will attract each other. So therefore, it will return to the non-charged particle. So what do you think? What will be the process in order to have it charging by induction? So the alternative is you let this positively charged move away from this particle. So you have to find a way in such that this positively charged will be eliminated from this object, so that it will be the protons will be outnumbered. So therefore, it is more on electrons. So if it is more on electrons, then we call this as a negatively charged. More protons eliminated, more magnitude of charges occurs on this object. So what will be the process? The process is to place the ground. So you have to put a ground. This is still a conductor, and place it on the earth surface, because earth is the storage of excess charges. That's why when the lightning strikes to the ground, it absorbs the charges, extra charges. Our electrification lines, at the power lines, they use the earth as the ground, because extra charges will put onto the ground, because the earth is the largest object. So therefore, it has the capability to store many charges. So therefore, if you do it, then this will be, the positive will travel into the earth. So in that case, this positive will be outnumbered by the electrons. So with this object, then this will becomes a negatively charged. Again, negatively charged means this is more on electrons. The protons are outnumbered by the electrons. Other protons are situated in the Earth's surface. So therefore, take note that there is no contact between the stand and the particle. So this will becomes a negatively charged. So notice that in conduction, the source charge provides opposite sign, positive, negative. Unlike conduction, it replicates its charges. Okay, so again, this is charging by induction. So therefore, if this is negatively charged, this will produce a positively charged particle. So that's it. This is the charging by induction, no contact. So in no contact, you have to use a ground. Now, another important in electrostatics is we should know the atomic structure. This is actually review. In atomic structure, we have the nucleus, the center. The nucleus is composed of protons and neutrons. So this is positively charged. While around the nucleus, a particle is kept on orbit, and we call this as the electrons. The electrons will orbit on the nucleus with energy. So we have the layer of energy. These energy are discrete energies. So this is the ground state level, then second state, then the last layer or the ring is the free electrons. These are particles that ready to conduct ionization process. So it will provide a subatomic particle in order to charge. This will become positively charged or positive ion or negative ion depending on the charging process. So this is the atomic structure. So we call this as the electrons. Take note, electrons have charge. And we have this is free or valence electrons. This has the highest energy among the electrons, the outside ring. And this one is the nucleus. Again, the nucleus is composed of protons and neutrons. Okay, so the electrons keep on orbit around with energy. So once this particle or electrons, which is closer to the nucleus, once gain with energy from outside, it will move, it will elevate to the next level. More energy, then jump to another level. If it is reducing energy, then it will move to the lower level. Okay, so this is we call this as the atomic structure. Now, take note that in electrons, these are particles. These are particles, microscopic particles, but still, we have the mass. So, somebody measured the mass of the electrons as 9.11 times 10 raised to the 31. This is very important in our study of electrostatics. So, you have to memorize this one. The mass of electrons is 9.11 times 10 raised to negative 31 kilograms. Now, this is a charge. So, therefore, there must be the charge of electron. And the one electron is equal to negative because this is electron. 1.602 times 10 raised to negative 19. The unit is coulomb. This is the unit of charge. Okay, then for the protons, take note, protons inside the nucleus. This is also a microscopic particle. It cannot be seen our naked eye, but somebody measures the weight, the mass of the proton. So the mass of the proton, MP, is 1.673 times 10 raised to negative 27 kilograms. So if you notice, this is heavier. The protons are heavier in the mass of the electrons. That's why electrons is keep on rotating. So, and take note that the charge of the proton is the same as charge of the electron. So that's why we use E. But this is positive. This signifies that positive 1.602 times 10 raised to negative 19 coulomb is the unit of, or the charge of the proton. For negative, it is electron. Actually, we are concerned with electrons because electricity means it is the motion of electrons. That's the conventional analysis. It is the electrons that travels, but the opposite direction of the travel of electrons in the conductor is actually current. So that's electricity. Okay, so this is heavier but the same charge. Now in neutrons, the mass of the neutron is the same as the mass of the proton. So it's heavy also, but the charge is 0. So we're not concerned with the neutrons. We are concerned with electrons and protons because they will interact because of its because of its charges. The interaction between masses are negligible. The interaction between charges are very much significant of the microscopic particles. Okay, so that's it. This review. Now, there's a comparison between mechanics and electromagnetism. When we say electromagnetism, this is the combination of electricity and magnetism because it was observed that when there is electricity, there is magnetism. Vice versa, in the presence of magnetism, there is electricity. So, combining this as one discipline, as one theorem, we call this as the theory of electromagnetism, which is actually studying about electricity and magnet. While mechanics, this is the study of interaction between particles due to its mass, and this is by force. Okay, so there are comparisons, there are similarities, and they have also the difference. Now take note that in this topic we are concerned with the electromagnetism, and it was assumed that we are done with the mechanics. So therefore we can relate these two. We have to connect this one by some analogies or similarities. So what are the similarities of this mechanics and electromagnetism? By the way, when we say physics, physics is just an interaction between particles. That's it. If you are asked what is physics, physics is an interaction between particles. So when we say particle, there are properties of the particle. We have the mass. Okay. So if you analyze the interaction between masses of two particles, the result actually is mechanics. That's why if we concern the particle about its masses, the heavier, the greater the momentum. Okay, so right, because we are concerned with the mass, we did not include the charges, because in mechanics we are analyzing or studying about the interaction between the mass. Okay, so for example, Earth has a mass. Now take note, Earth is the largest mass. Okay, this is the largest. We stay at the surface. Why? Because of the presence of the gravitational acceleration. So because of its mass, and if we have this an object which is near to the Earth, okay, assume that it's very near to the Earth, the distance of height is. So this object is subjected by a force according to the law of universal gravitation. Two objects interact each other. So the result is the gravitational force. Whatever force, this is the force that the Earth exerts on the object, while there's also an object, a force on Earth exerted by this object. We call this as the gravitational interaction because of its mass. Okay, so the result of this object, small object, will be attracted towards the ground. That's why we stay at the surface, because of this gravitational acceleration, gravitational force. This is the force that the Earth exerts on us. So suppose this is the object, the gravitational force is always towards the radius always. So anywhere in the surface will be attracted towards the radius. So we'll stay at the surface. Why is it? Why it happens? The reason is because of the acceleration due to gravity. Now, the acceleration due to gravity depends on the mass. The heavier, the greater the acceleration. If you notice, if you recall in your previous physics, the acceleration of Moon is 1.67. Compare it with the Earth. The Earth is 9.81 or 9.80. This is the average acceleration. Acceleration is location specific. It depends upon the location. But on the average, we use the 9.81 meters per second squared. So, the reason why this is 9.81 because of its mass. The Moon is 1.67. So, Moon is smaller compared to Earth. That's why Moon is keep on orbit. Sun is, the acceleration is almost 274 meter per second squared. So we can expect that it is a large mass. Okay, so again, the 9.8 is due to the mass. So this is actually the result. Why is it that we have 9.81? So everything will be attracted. Why? Because of these lines. These are the gravitational lines, the Earth's gravity. So everything will be attracted towards the Earth. Not repulsive. Okay? Always attracted. Okay, so this force, actually, this is the force that the Earth exerts on this object. Force of gravity. We call this as gravitational force. and this is gravitational acceleration. Okay. Now in mechanics we studied, because we have the force and we have the displacement, we have now the gravitational potential energy. This is the energy work done by the gravitational force. So in mechanics we study gravitational potential energy, and we have the kinetic energy. Why is it that we studied kinetic energy? Because the particle moves with displacement. So now moves because of the force and its displacement, then there must be a change in position. The change in position will create uh, work, and the work is actually composed of kinetic energy or gravitational potential energy. So we studied this in our previous basics work done. Okay, then we have torque and so on. We studied momentum, everything. So all those topics are belongs to mechanics, and we use it as the interaction of masses. Okay, so now what will happen if we momentum? What will happen if we analyze the interaction between charges? Q means the charge, M is the mass. So interaction of charges is actually electromagnetism. If we analyze the interaction between charge, then we are studying about electromagnetism. So this is we are concerned in this video and incoming videos, the interaction between charge. We will ignore the interaction between masses, because when you compared it, microscopic particle mass, the interaction due to gravity is negligible, but the interaction between charges is much significant. So similarity, okay, suppose we have this charge, a stationary charge, let this as negatively charged, negative Q. Q means charge, big letter Q, it can be any. Now suppose I have a charge, positive charge here, a small charge, then just like Earth, this will experience a force due to this charge, and we call this as electric force, while this one is gravitational force. So the tendency is this will be attracted. Why? Because this is positive, negative. So this will be attracted towards the stationary charge. Okay? So that's it. This is the electric force. Why is it that this is electric force? Because these two charges interact each other. Now, the lines that object will be attracted or repulsive are the lines called out as electric field lines. So therefore, there must be an electric field at any point of this. And the analogy is, in mechanics, this is actually acceleration in mechanics. Okay. So the analogy of acceleration of gravity is the electric field in electricity. So we will study this. There are a lot of activities done on this, how to obtain electric field. Okay, what are the formulas and how it is being used. And this is very important in electro or in electricity. Even in magnetism, this is very important, played an important role. So, okay, why is it that there is electric field? It's because of the charge. That's similar to why is it that we have this acceleration due to gravity? Because of its mass. So, this is directly proportional. So therefore, this must be directly proportional also. So these are the lines. So any charges will be attracted or repulsive depending on the sign. Take note of the law of signs. Positive, negative, different charges attract each other. So the reason why it is being attracted because of the electric force, or we call that as Coulomb force. Okay, so there, in mechanics, we call this as gravitational force. Now, because of this force, we can calculate the energy of that electric force applied. So we have the electric potential energy. In mechanics, we call that as gravitational potential energy because we are concerned with gravity. This one, we are concerned with electric potential energy. The symbol used in electromagnetism is the same symbol in mechanics, U. So in all physics, the symbol used for the gravitational symbol or the electric potential symbol are the same, big letter U. So K is the kinetic energy. By the way, the question is, are they have the same formula for the potential energy and the electric potential energy? The answer is they must have different. Because this is due to mass and this is due to charges, but there are similarities. Now this one, kinetic energy, whatever formula here is the same as, because the kinetic energy is actually the energy possessed by its velocity of the particle. So this is also the velocity of the moving charges. So instead the formula is 1 half m 1 half mv squared. Then we have also the work done by charge. Okay, but we are concerned with electric potential. So along the way we will study this one. Gravity, electric potential energy, electric potential, and we have the voltage, because the voltage will be our concern in electrostatics. How much voltage stored on that interaction, and this is the source of energy. That's why it conducts current because of the supply voltage plus the conductor. Okay, so then how? Now, by the way, Isaac Newton, in his law of universal gravitation, provides this formula that the force of gravity is the gravitational constant. You have to review your notes, times the product of the interacting masses. These are the interacting masses, and divided by the square of their distance. So we can calculate the amount of force or gravity using this formula. Now, in electricity, what do you think? What will be the formula? Now, in the next video, we will understand that the electric force is actually K, where K is electric constant, times the product of the interacting charges divided by the square between their center to center distance. So therefore, look at this formula and this formula. The only difference is what? We have the gravitational constant and we have the electric constant. This is the product of the mass and this is the product of this charge. This is the interaction of charges and this is the interaction of masses divided by the square of the center to center. When we say center to center, center is Earth, center of the object. This is also center to center, which is r squared, inversely proportional, which means that if the objects away from each other, it has a lesser amount of force. Closer to each other, the smaller, the greater. Okay, so notice the similarities. Okay, now in law of universal gravitation, if you derive the formula, you will arrive the formula for the. By the way, when we say force of gravity, it is weight, and we are very familiar to this formula. Weight is mass times gravity. So therefore, these two must be the same. That's why if you combine these two, you will result the formula for the accelerations. If you combine these two, the result is actually the acceleration. By the way, before that, in electricity also, quite similar. The electric force, we will learn this one as we go on our topic in the next videos, coming videos. So, the charge times electric field. So, if you multiply this charge by electric field, the answer is force. This one, if you multiply the moving charge by the gravity, the answer is gravitational force or weight. So, take note of the similarities. Okay? So, as I've said, if you combine these two, using the law of universal gravitation and the definition of the weight, you will arrive the formula to calculate the gravitational acceleration as the G. Okay? Acceleration is equal to the gravitational constant times m over r squared. By the way, G is constant, 6.67 times 10 raised to negative 11. Negative 11. The unit is Newton meter squared per coulomb squared. Per meter squared. Actually, this is we discussed this in the General Physics 1 Mechanics. Now, in electric field, take note, electric field is similar to the acceleration, gravity. So, similarly, the electric field also is Q over R squared. K is the electric constant. Electric constant is approximately equal to 9 times 10 raised to 9 Newton coulomb squared per meter squared per coulomb squared. This is Newton meter squared per kilogram squared. K is Newton meter squared per kilogram per coulomb squared. So the unit now, if you substitute it here, the unit of coulomb will be cancelled, and the unit of meter squared will be cancelled, and therefore the unit of force will be in newtons. Okay, so this is 9 times 10 raised to 9 newton meter squared per coulomb squared. And this is charge, and this is R. This is mass, this is R. So look at the similarities. We will learn this in the next succeeding videos. So keep on watching. By the way, talking about gravitational potential energy, we learned that when we say gravitational potential energy, it is mgh. This is possessed by height. So the energy, when you an object with height from the ground, it has energy. The higher the height, the higher the energy. So this is actually the formula, and we derive this in mechanics. So what about the electricity? In electricity, the electric potential energy is UE is equal to Q. Look at this, Q, electric field, D. So mass, charge, gravity, electric field, height, distance. So they are almost similar, but it differs with the property, the charge and the mass. Okay, so the difference is, this is the difference now, because on Earth is always, the acceleration is due always towards the radius of Earth. That's why everything will be attracted. But for electricity, if we have another particle here, whose charge is Q, suppose the same, and we have, here comes this moving charge. So this is subjected not only this force, attractive discharge, there is also a force that this charge exert to this charge. Okay, so the net exert, because this is vector quantity, so there must be a net force. So net force is in between, because if they have the same magnitude and the same distance apart, then this will be moving at the center towards the center of this line. So therefore, this will be the result if we have two surrounding charges. So there are two forces that acts on this charge. Okay, but in Earth, there's no other adjacent particle which have greater amount of mass, because if Earth, or if the sun is very close to Earth, then everything will be attracted to the sun because of its mass, heavier mass. Okay, so for the charge, there's a visibility of superpositions of the forces depending on the surrounding charges. So this will be the. Now another thing is, if we have this as negatively charged and this is positively charged, take note that this will be negative, it will be repelled. So the tendency is this particle move away, unlike in Earth that is always attracted. Why? Because we follow the law of charges. So if this is positive also, this electric field is outward. For electric field negative, this is inward. So therefore, this will be attracted. Okay? So that's it. This is very important basic information for the introduction to electromagnetism. The electrostatic is the first topic in electromagnetism. We will proceed to dynamics and so on, going to magnetism. So the question now, and will be answered in the next video, how much force on this charge due to this charge. So that's the topic is calculating the electric force between charges using the law, Coulomb's law. If in mechanics, the force was calculated using law of universal gravitation of Newton, then in electricity, the force can be calculated using Coulomb's law. And the Coulomb's law actually is patterned with the mechanics. And the Coulomb's law was invented by or discovered by Charles Coulomb. Okay? So that will be our next topic. Thank you for listening. Good day. Have a nice